Alright, let's go ahead and get started with Lesson 4, Experimental Error, Part 1 of this lesson. We're going to first take a close look at two important vocabulary words, accuracy and precision. In our everyday usage of these two words, we often interchange them and think they mean the same thing, but it is not true. There is a difference between accuracy and precision, and you need to know what those differences are. Alright, so accuracy by definition refers to how closely individual measurements agree with the generally accepted correct value or literature value. Precision indicates how many significant figures there are in a measurement. So the more significant figures, or in other words, the more decimal places that can be recorded for a measurement, the more precise the measurement is. Alright, so this table here that we're going to fill out will give us a more in-depth look at accuracy and precision. So when we take or do an experiment, we're going to gather data points. And it's important to determine if a single data point in our experiment is accurate and precise, as well as to take a whole bunch of data points from different trials and average them together and determine if the average is accurate and the data points themselves, all those data points themselves, are precise. So this table will help us here. So let's look at single data points first. Alright? So what we can see here is that if we have a single data point, it will be accurate if it is close, that single data point is close to the literature value, or what we consider the true value. A single data point is considered precise or has precision if it has a lot of decimal places or significant figures, because the more decimal places that can be recorded for a single measurement, the more precise our tool is. Alright? So that's for single data points. What about for a set of data points? Well, when we do an experiment, and like I said earlier, and we gather a whole bunch of data points, we're going to average those data points. If the average value is close to the literature value, then we'll say it is accurate. So it's important that when you do an experiment, that you do it multiple times or have multiple trials. For precision, a set of data points are precise if all the data points are very close together. Alright, this basically refers to consistency. So if you can look at a bunch of data points and you can say those measurements that you're making are consistent, they're agreeing with each other, then they are precise data points. Alright? And if the average of those data points then is close to the literature value, then they're also accurate. Alright? So make sure you really understand this table. It's a very important table. Study it well for the quiz. Alright, so let's look at an example here. So we know that the normal boiling point of water at sea level is 100 degrees C. Right? If you use a mercury thermometer, you could measure that normal boiling point of water to 99.5 degrees C. Right? So I'm going to actually highlight that. So this is the true value, or the literature value, of the boiling point of water, 100 degrees C. Right? A mercury thermometer can measure it to 99.5 degrees C. Now, if you use a special data probe, the data probe can measure to 98.15. So let's compare the two. The mercury thermometer versus the data probe. Which one gives us a more accurate measurement? In other words, which one of these gives us closest to the true value? If you said the mercury thermometer, you would be correct. The mercury thermometer is more accurate. However, you will see that the data probe is more precise. So why is the data probe more precise? Well, if you look at the number of significant figures, for the mercury thermometer, you have 3 significant figures, and for the data probe, you have 4 significant figures. Since we have more significant figures with the data probe, that measurement is more precise. Alright, so that's how it works. Alright, let's look at an experiment here that was conducted by 4 students. Student A, B, C, and D. These 4 students took an object, some object, and they wanted to determine the density of that object. Each student did 3 trials, and then after their 3 trials, they averaged their 3 values together and got their average density. Alright? Now, from what we can learn from this is that the actual value, or the actual density value for the object they were measuring, looks like it's 5.2 grams per milliliter out to 2 significant digits. Okay? So let's look at student A. And what we want to do for student A is we want to see if the data for student A for the 3 trials is accurate and precise. Okay? So what do we think? Let's look at our 3 data points here. When we take those 3 data points, we average them together, and the average value is 5.21. Alright, now, is that 5.21 close to the true value? The answer is yes. So what we're going to say is that student A's data is accurate. So let's see, we can student A. Accurate. Now let's look at its precision. Alright? To determine if it's precise, we have to look at the 3 data points of the 3 different trials and determine if those data points are very close to each other. In other words, are they consistent? The answer would be no. So we would say that student A has accurate data because its average is 5.21 and close to the actual value, but its values here are all very different from each other. So it's not a very consistent in the measurements here, and so it's not precise. Okay, so let's look at student B now. So student B's data. Let me erase student A's stuff. We'll just look at student B here. So student B's 3 values are right there, and its average value, oops, wrong thing, highlight it, average value is 5.22. Is that accurate? Absolutely. Student B's data is very accurate. It's close to the actual value. However, what about the 3 data points? Are they consistent with each other? Are they similar? Are they grouped close together? And you would say our groupings are close. They are consistent, and therefore student B also has precise measurements. So student B is accurate and precise. Alright? So let's look at student C now. Compare its data points. There's its 3 data points, and the average value is 4.21. Is the average close to the actual value? No. So student C is not very accurate. However, do we have some good precision there? And the answer is yes. Why? Because the data points, these 3 data points here, are very close or very consistent to each other. So we'd say that student C is not very accurate, but he does have pretty good precision in his measurements. All right. Let's look at student D, our last student. All right. There's its 3 data points, and the average value of those 3 data points. Is student D accurate? It could be better, definitely better than C, but I'm going to go ahead and say that student D is not that accurate. Alright? What about student D's precision? Is its 3 data points in trials 1, 2, and 3, are they consistent? Are they close to each other? Are they grouped well? And the answer that I would say is no. So I would say that student D is not accurate and is not precise. Alright? Alright, so now what we're going to do is we're going to look at trial 1 for all 4 of these students. Okay? Trial 1 for all 4 of those. Okay? Now, out of those 4 data points for these 4 students, which student has the best precision in a single data point? Alright? Now, to do this, we have to look at the number of significant figures. Alright? We're going to compare in other words, which student is using the most precise instrument. Alright? So to determine which instrument is most precise is based on the number of significant digits. So student A has how many significant figures? If you said 4, you would be correct. Student B only has 3 significant figures, and student C also has 3 significant figures. And student D, well, has 2 significant figures. So the winner is student A with 4 significant figures. Student A is using the most precise instrument because it has more significant figures, more decimal places. Student B and C look like they're using the next precise instrument. They're probably using the same one because they have 3 significant digits each. And then student D is using the least precise out of all of them. Alright. So, the question is, out of trial 1, which student out of those single data points is more accurate though? Well, student B would be, because its value is 5.20, so it's very close to the true value. Alright, student A would be next, then C, and student D would be the least accurate in single data points. Alright, so hopefully this makes sense to you. If you need to review this section, I would. On the quiz, I'm going to give you something similar to this idea, where I'll give you a set of data points and you'll have to determine which ones are accurate and which ones are precise. Alright? Well, that is it for this lecture video.